Garrett, I'm going to turn it over to you.
Fantastic, thank you. How are you all doing? So this is actually the second time I am presenting this presentation to Central Florida. The funny thing is, it's the first time I was actually in the Florida Biomedical Society meeting about a year ago, right? And presented this, and I was thinking, man, I wouldn't get a lot of people. I would just, you know, have one or two, and I had a packed room. And I realized that this area is in need of people who are transitioning from biomed to imaging. And so this presentation is here to help you get the skill set required to make that transition from biomed to imaging. Perhaps you want to augment what you already know. So hopefully this will be very fruitful for you. That's the goal for it. So we're going to call it Introduction to DICOM. And so I'd like to just put in a slide here. I used to just jump right into the subject matter, but I've learned that people want to know this stuff. Who am I and where do I work? My name is Garrett Seeley. I am an associate professor of biomedical equipment technology at Texas State Technical College, Waco, Texas. Boy, that sounded rehearsed, didn't it? So I've had to say that a whole bunch. Texas State Technical College is one of the largest graduates of biomeds in the nation. We are the largest outside of the military. We graduate approximately 50 people per year. We have 2 facilities that are teaching biomed, and that pretty much eclipses everyone else's except for military. Military does up close to 400, but they're dealing with a lot more attrition than most other places. So our students actually learn on hands-on labs. We actually have real equipment. We actually have 2 CT machines now. We have an old CTI and a 16 slice light speed, I believe it is. So pretty GE heavy. In fact, actually GE corporate said that we were the biggest program they had no idea they were supporting. So let's talk about what we're going to talk about today. We're going to talk about DICOM. For those of you that do not know it, DICOM is the standard for communicating picture images. If you didn't know that, you probably would have signed up for this class, right? So it is the standard that is used by your PAC systems, which are picture archive communication systems. And it is the imaging side of electronic medical records, electronic health record side of things. So let's just go ahead and move on for that. It was created in 1991. Actually, prior to that, it was the ACR NEMA standard, but it was officially changed to DICOM in 91. So this was a slow road that we went through in replacing film. In fact, actually, we were using film all the way up until what, 2008? Something like that, 2009, when finally everyone was required to go digital. And so when they were required to go digital, they used DICOM as the standard, and we just sort of added to it as time goes on. So forgive me if this seems sort of cobbled together when it comes to these additions. Let's talk about the basics on DICOM. How does DICOM work? I've done a lot of presentations on this, and I think that the easiest way to explain this is to look at how mail works. I'm going to assume everyone sent a letter before, right? You're going to all need to remember that. What was it like to send a letter? And I want to ask a specific question. What was it like to send a letter from a person in an apartment building to another person in a different apartment building? Well, there were some things that you would need. You would need the person's name, their street address, and their apartment number. If you left any of those things out, it just wouldn't get to that person. You know, apartment numbers don't seem important until you start sending letters to things that have 1,000 apartments at those locations, right? And now you don't have the ability to reach somebody without that apartment number. So the apartment number is very important. So what is needed in DICOM? Well, 3 things that are just like name, address, and apartment number. Those 3 things are the AE title. We call that an AE title, not an application entity, though that's what it stands for. So the AE title, which is synonymous to the name of the machine. the IP address, which is like the street address to include zip code and city and all that other stuff. And then the port number. The port number is like a apartment number. Okay, so remember that you can have a full street address. The letter gets to an apartment complex. It has a name on it, but if you don't include that apartment number, it won't go to the right apartment. Now, software is a lot like this. Software is like a person living in an apartment. We have onesies. No one's doubling up. Every piece of software gets its own apartment, right? Those apartments are called ports. It's the easiest way to understand a port. I just got done doing a whole speech with people that were learning cybersecurity, and we talked about ports. Ports are the things that your firewalls are looking at. They're the things that your access control lists are looking at over the network, and they're how you filter your traffic in a general format. So the three big settings. By the way, just like when you mail something from one person to another, you need to have all three of these pieces of information on both sides. DICOM must be set up the same way. Let me say that again. Each machine has to know the name of the machine that's sending information, the IP it's coming from, which means we can't have IPs that change, right? And the port number. They need to know the port number for that software. And that's all going to be both sides of the communication, just like sending a letter. Sound good? Cool. That's your first thing that you're going to have to remember. If you're taking notes, you need to write those down. AEIP port, right? So those are the three things that must be present. I sort of got ahead of myself. They have to be present on both ends. That is, you have to have each of these set up on both machines, and you tell the machine, hey, your name is this, you are at this IP, you're using this port, you're going to talk to this foreign machine at this IP with this port. I know I'm being very redundant on that, but this is one of the most foundational things on DICOM, okay? Another thing that's really foundational on DICOM is the concept of an association. So you've probably heard that if you worked in radiology briefly. There's an association number between this machine and that machine. An association is actually they call it a session number. I apologize. The association is the communication itself that's going to communicate. It's in the session number that's going to identify that. We're going to communicate from a user to a provider. Concept here, we call it a service class user. That's the source of an image. The service class provider is a server that you're talking to. So that's a very important thing to talk to. Now, here's what's cool. It's cool for me. It's a little confusing when you're starting. These are software modules running on a machine, right? These are like softwares running in those little apartments inside the machine. So nothing says I can't have one software on a machine that's a user, and then in a different apartment, another software that's a provider. So I can be both the source of a transmission and the receiver of a transmission, or I could just be the source of a transmission, or I could just be the receiver of a transmission. And the way they describe these things is with SCU. They're an SCU and SCP or both. Okay? So when you're looking at descriptions of that, that's how to understand it. Also, I want to tell you that this software is a layer 7 application. For those of you that really care about that, like HL7, it's health layer 7. This is a layer 7 application as well. This is one of the most important graphics I've got. And I'm going to walk closer to the screen so that I can actually walk through it, because this will describe to you the actual flow of data for a typical work interaction. You know, let's say we've got a person that goes into an ER. They have a broken wrist, potential broken wrist, right? We're going to go ahead and we're going to make a request for an X-ray. That is actually going to go here on this red bar. I did it red because typically as an imaging person, this is not something you would work on. This is actually the HL7 backbone of the hospital. Somewhere in there is a device called an interface engine. The interface engine is essentially the flow control for the HL7 information in that hospital. The interface engine gets a request from ER for an X-ray. Here's the patient information, right? And it tells it, doesn't just say I need an X-ray. It says I need an X-ray of a patient's wrist ordered by this physician, for this patient. Here's the patient ID. Here's the date, and it gives all the particular information. The interface engine goes, radiology needs that information. So see, we start here at the interface engine, and that's what I've got numbered all the way on the right-hand side. That interface engine communicates to the HISRIS interface, that's often called the broker. The HISRIS interface is actually going to take that information and convert that information into a DICOM format. It actually starts to build the DICOM file, but the file is incomplete. The file does not have the picture in it. And we'll talk about the bits of a DICOM file later on in the presentation. So it sends that DICOM file to the modality work list server. Now the modality work list server is a queue. All this does is it tells the modalities, and a modality in X-ray is a type of X-ray system, like for example, ultrasound or CT or MRI. Those are all modalities, right? The modality work list server works as a giant queue for all of the modalities, and it basically says, okay, this is the next patient. Here's the patient information. I've got part of the DICOM file. I've been able to put all the patient information in it, but I don't have the image. Your job is to give me the image, right? So the modality itself says to the work list, okay, hi, I'm ultrasound number 2. I need the information for things that are in my queue. The modality work list says, okay, here's your queue, right? The user then goes ahead and scrolls down and says, okay, I'll take this patient who's next up, right? And then the modality work list sends the file to the modality. The modality does the study. It gets all of the images, puts them in. Sometimes it does them in separate files. Sometimes it does it together in one big file. I think we'll talk about that later on. It does all of the images, gets all of the related files, and then once it's done, it sends the information to the workflow manager, which is the DICOM equivalent of an interface image. Our interface engine, I'm going too fast. The workflow manager then updates the archive and also holds a queue for the doctor's workstations. The doctors, when they're available, you notice a lot of this is when they're available. So the modality is when they're available, they get the queue from the modality work list. The doctor, when they're available, gets their queue from the workflow manager, right? And the workflow manager tells the workstation, yes, I have this file. It's got a complete image. Here it is from the archive, goes to the doctor's workstation, right? The doctor's workstation's job is to then transcribe and then give the text back to the interface image. Or I said that same way twice. Interface engine. It gives the information from the transcription to the interface engine. The end result here, if you'll notice, HL7 sends a request in text for a patient study. Radiology hears that. They do all their stuff that we can actually make adjustments to, right? Then the doctor pulls up the image, does their transcription, and gives text back to the interface engine. Generally speaking, as a general rule of thumb, if you've ever had an X-ray or had a loved one that had an X-ray or seen a patient that had an X-ray, Your physician or the primary care physician didn't care to look at the image. That was the job of the radiologist. What they wanted was the results, right? Somewhere around 80% of the results are inconclusive or negative. No, the person doesn't have a broken wrist, they just got a bad sprain. Right? That's great, right? This model is what you need to look at for context of the hospital. Everywhere that touches this green line has to have an AE, IP, and port. They have to know the other person they're talking to. If any of that stuff changes, the security of the system goes, nope, sorry, something's wrong, backs off. And there's a lot of freaking settings. Anyone work briefly in radiology? Yeah, there's a lot of these settings in DICOM, isn't there? And they all have to be right on both ends. So we've got our hands full from a patient records side as biomeds, just maintaining the radiology side of things. What do I want you to do to get skills? In order for you to experience this, there's one really great way. Show of hands, I got a high-speed internet at home. Hopefully that's every hand in the room, right? Show of hands, I got myself a laptop at home. Anyone know that? Show of hands, I got 2 laptops or 2 machines at home. Fantastic. Then check this out. Here's what you can do. If you have 2 machines, you can do it on one. It's just clearer from a lab perspective. If you do this on 2 machines, I want you to download 2 pieces of software. There's the KPAX software, and then there's Ginkgo CAD. And I've got links on this presentation so that you can look up those pieces of software. Another thing that I would recommend is perhaps coupling that with another software that I've got, Conquest, down here. These are the KPAX and Ginkgo are workstations. Actually, Ginkgo can work as a server. Conquest is just a standalone server. These software are free. When I am teaching my students how to work on DICOM, I send them out and I have them get these software. I have them download and set up these softwares and do communications back and forth. There's something called a DICOM ping. It's also called a DICOM echo. It's also called a DICOM verification. You can do these things and verify that the software works. What if you want to transfer an image? Easy. You ready? You can go online and download free DICOM images. They're out there on the web. Just type it up and go, I want to download a DICOM file. Google's very helpful on some really unusual stuff, and this is one good example of it. So I suggest you all go home and build these labs. The only way to get your skill set up is by doing it, right? So go home, play around with the software, and set up these communications and simulate these things. By the way, to look back a little, the Conquest would substitute for the workflow manager. It is the archive. The Ginkgo or KPAX would be workstations. KPAX is more of a doctor's workstation. Ginkgo is a 3D CAD workstation. Notice I've got a CAD system up above there. We'll talk about that in a little bit. So, things I want to recap: AE, IP port, right? Set them up on both sides. Make sure you do a DICOM ping so you can verify communication back and forth. It is also called a DICOM echo. It is also called a DICOM validation. Understand that there's a couple of things that you have to understand about the association. The concept of a push or the concept of a pull. Push means I'm at the modality and I'm sending an image, right? Pull is I'm at either the modality or the workstation and I want to query for a list of things, and I want to retrieve the image. Now I know what you're thinking is, what do you mean by pull when you're on modality? And I said that you send out an image. The modality has to do a query and retrieve from the work list manager. I know I'm throwing a lot of terms at you all, speed of light. To be perfectly honest, I've only got another 40 minutes to go through this, and I got another whole section of the presentation. So forgive me if that was very fast. In these software, one of the things I would want you to look for is the error log or the log. The log itself breaks down an association in 7 elements. Here's the great thing. It'll only use 5 of them for communication. The 7 elements are at the bottom here: request, acknowledge, the data, release, acknowledge. Very rarely will you see request denied or abort, but they are the other steps. So the 5 main ones are: I request a communication, I acknowledge your communication. Let's go ahead and talk. In fact, actually, let me go to the next slide. I've got a service class user, that's a client, that's a modality, right? It wants to talk to a service class provider, that's the machine that, you know, like your archive, right? So it says, hey, can we talk? Well, sure, you're on the list, let's talk, right? Now here's what's interesting. This the user then says, okay, I'm going to give you a command. I want you to do this with this information. So it says, store this, here it is. The service class provider then replies back and says, okay, I'm done, got another? And then we run that loop over and over and over and over and over. Yeah, I got another, here, store this. Yeah, I got another, here, store this. Over and over and over till all 150 images are sent from your CT, right? At the end, notice the user then says, hey, I'm done. We can stop talking now. Server replies back and says, okay, we're done. Notice there's a couple of peculiar things about this. The user is what starts and ends the communication. This is an on-demand system. The servers don't really control things. A lot of people look at servers and they think, well, servers are really powerful, and they're used to things like Active Directory. They're used to things like control lists, where IT sort of being a little tyrannical and showing you this works this way or this doesn't. But in fact, actually, I want you to change the way you look at servers. Servers are more like waiters, at least in my mind. The users are like the customers. They're sitting at the table. Come on over here, man. I need help. They snap a couple times, wave a person over. Server's like, yes, how can I help you? Now, when you look at that, look at this exchange, it becomes more important to see it from that model. When you look at an error log in DICOM, these are the steps it goes through. Step 1, request. Step 2, acknowledge. It skips step 3. Step 3 would be a you're denied, right? Step 3 is a you didn't set me up right. Sir.
The user is not in the list of.
Exactly. If the good question, I'm going to restate that for people that are watching online. The question was, yeah, is it because it was not set up correctly on both ends? Absolutely. If you do not set up on this service class provider the user and say this user is going to talk to you, and they're going to send you ultrasound images, and there's AE, IP, and port are right here. And if those things are not correct, the server goes, nah, you're not on the list, man. I'm not supposed to talk to you. Denied, right? Notice the 4th exchange is just a lot of data, but you're going to see there's 2 different types of requests. A, which is association start or end, and C, which is command data. You know, command store, here's the information. Doesn't even wait for the server to say, okay, I've received the request to store. It just goes, here, store, here's the information. Server replies back, yep, I'm done. And then it's just a loop. Till the user says we're done. There again, much like the customer at the table requesting that the waiter do something, right? And then the abort is just, I saw something funky. And abort happens either direction. So there's either a request denied or abort. And much like a military type of communication, if anyone on any side hears abort, anyone ex-military, you ever hear the phrase line compromise? What should be the next communication? You got it right, you hung up. That is the last set of words said there, right? Abort, they take more of a military approach, more of a line compromise. It's not quite so severe, but it's very similar. You see an abort midway through communication, done. That's the last line in that log, right? Now, things have to see something pretty severe for that, but it's there. Okay, so next thing, what did we use DICOM for? Well, obviously storing images, right? But also we use those work lists for compiling what the department has to do. That's why you're going to hear your department screaming all the time about session numbers. And those session numbers are all about the association. They're asking for, what do I need? Well, this session number, it tells you what you're going to have for that use case. Okay? I'm sort of butchering the session number. The associations themselves, there might be several associations associated with one session number. The session number is that visit for that patient. Okay? That access to care, which is literally where the name came from, access. Right? So, yes, sir.
Can the session be retrieving of the old image?
I didn't hear you. What?
Can session be retrieving of the picture from the server?
Yeah, you would use the same session number for that patient's visit for that time, generally speaking. So when the doctor uses, their queue to see what's next, the session number they see should match the session number that the radiology was using for their image. Sure.
How do you, in the real example, where do you fit that? What is?
Okay, so the question was, how do you fit the work list into everything? Well, the work lists themselves, there's essentially two work lists. There's a work list for what the rad tech is going to do, kept in the modality work list server, wherever that machine is. And it's typically its own separate server, right? Or a virtual server or something. It's for functionality purposes, it's its own standalone machine. And then the doctors themselves have a doctor work list that is kept on the workflow manager, which is actually sort of like the equivalent of the interface engine, only the interface engine in the HL7 has much more direct command. The workflow manager is much more concerned with things going into and coming out of the archive. So it really is there. Now, if I may go back with this, because it's controlling access to the archive, to look back on that slide, you'll notice that the workflow manager, I don't just have one, I have two. The archive itself is on a separate network behind the workflow manager. And the workflow managers themselves talk to each other. Theoretically, the entire weight of the department's needs can be ran by one of those machines. The reason why you have a two-headed thing is so that if one is not available, the modality or the doctor's workstation has a priority list. I'm primary on this one, I'm secondary on this one. The primary says it's busy, I'm going to go to the secondary, or I didn't get a response from the primary within a certain amount of time, I'm going to ask the secondary. And the workflow managers, they don't take it personal, right?
So if you had the radiology echo
then you had a new study, would it be the same session?
That's a good question. The question was if I'm having multiple studies done under a particular session number, is the study, for example, you use like a CT and then a nuke med, do they go under the same session number? I'm going to give you the honest answer. You ready? I don't know. That is a particular workflow of the department. As a technician myself, I've just been maintaining the network to make sure that the network will perform with that. That's an operational question for the radiology department itself. Best answer I can give you is I don't know that one right off. Honestly, that's an operational thing for that department. Does anyone have any other question? I do know where it's going to be stored in the archive. It's going to be stored under the same, there's like a study and then there's a series. It'll go in as a series under the same study. So my gut tells me it would probably be the same session number, but I'm not 100% on that. I do know this, the person who manages the locations of those files, that's going to be your PACS administrator. PACS administrators have had split studies and merge studies before. So if it gets put under the wrong session number, they can change it. It's a good question though. Anyone else have a question on the setup of DICOM or the structure and the flow of DICOM? This is, by the way, what I wanted to do for you, is be able to fill in the gaps on those operations stuff. So sorry, I couldn't really nail that one. Any other questions? Okay, let's go on to the next portion then. And I want to remind you, oh, I'm not really where I need to be. Okay, so some of the things that were on there that I didn't really talk about, that I just made references to, and I'll be perfectly honest, we're already doing most of this stuff. Computer-aided detection, CAD systems. Sort of like, I used to tell people it's like CAD is sort of like tax software or turn-by-turn navigation. Think of it like an AI who went to med school, whose job is to read images. Now, you would think that doctors would be very off-put by something like that, but they were very smart. They embraced it. Said, oh, look at that. You get an automatic second opinion. Doesn't replace a person, though. And they were able to get that pushed through for legislation on certain things like mammography. It's just standard practice now to have an AI second opinion on every study because it's so easy to miss things, right? But we're seeing CAD in other applications as well. It's just a software reading data. So I might hit the workflow manager with an information. The workflow manager, much like the interface engine, goes, oh, that has to go to the archive, but that also has to go to CAD, right? And much like your question with the session number, CAD does its own series and says, oh, look at that, I got a CAD result. That goes in as another series under the same patient study. Right? And so that's something that's important to know about. The next one, MPPS. This is sort of a part of a communication back. If you have a patient going into CT, would it be nice for housekeeping to know that they're out of the room for the next 45 minutes? So with MPPS, it's that. It's the CT can report back to the HISRIS interface so that it reports back to the interface engine and texts out a housekeeper to know that you're going to be tied up with this patient for the next hour. Now is a good time to clean the room, right? And MPPS does communication like that, but it's also there for the patient. If your loved one was in CT for an hour and you went to the desk and went, so where's my dad? And they said, gee, I don't know. Is that the answer you want? Or would you want, well, hold on, let me see real quick. Let me query the interface engine, what's going on. The interface engine says, oh, that person's in CT. And then they look at you and go, oh, looks like he's going to move to CT. He'll be there for about the next hour. Why don't you wait outside the room? Is that good Is that a better answer? Isn't that the answer you want? You see what I'm saying? So with with MPPS, I almost said HTTP, with MPPS, we're sending information backwards so that HL7 knows what DICOM is doing. That's a setting up most of the time on modalities. Okay, so we're also doing voice transcriptions. We're also seeing DICOM go into weird places. DICOM into ER. I remember when I was working in it, I asked, well, why does DICOM need to be in ER? And I had a nurse pull me off the side and go, listen, when we get battered spouses coming in here, we need to take pictures of what's going on. Do you want that stored? I went, yeah. I went, okay, we need DICOM, right? Lab, we take tissue samples, we need pictures, right? Surgery, GI. Look, we can do video. Video is just pictures at 15 or better frames a second, right? So these are all things that DICOM is doing. Does anyone have any questions as to where DICOM is going? Okay, great, we'll move on. We do only have about 20 minutes to cover the next bit. I'm going to skip over the recall things. Those of you that are looking at this, you know, at a later time and after a break, you can actually go through and you can go through all of the summaries of the last things that we talked about. I'm going to actually go on and talk about the bottom portion of this slide. We're going to talk about the settings of the exchanges, and we're also going to talk about headers and conformance statements, and that's really the next very important part for us to talk about. First, I want to tell you about the DICOM file itself. The DICOM file itself has two components. There is a header, and then there's the image, as pictured here on the right. Of course, we don't really store an image quite like that. We store an image like ones and zeros, and most of this stuff is just text, right? But we do a technique called encapsulation. We take the image data and we wrap it with a header. The header has all the patient information, also has all the information as to how the study was taken, also has all the contact information for the physician. It also has some of the relevant study data. That's a lot of data, isn't it? We have a lot of information in on the DICOM file itself. The image itself is just a JPEG. But we just put the JPEG data in there. Now, JPEGs do have something called metadata where you describe what the picture is. It's maybe a quarter of a page long. A DICOM header can be 20 pages long of information. What position was the patient in when the image was taken? What were the settings on the machine? You see what I'm saying? There's a lot of information we want to capture. And that all becomes part of the protected health information of that patient. Okay, so there are some settings when you start doing settings in DICOM that I want you to understand, and I'm just going to explain them briefly. There's something called a service object pair. This is how we identify what a machine is and what it's capable of doing. I am this machine and I do this. That's all a service object pair is. I am this machine and I do this. So we have these things where it says, hi, I'm an SEU. Here's my SOP. My number is this. And I transmit that to a server. The server looks at it and goes, oh, you're an ultrasound. And you do what's called multi-frame images. That means you're going to send me one header and 15 images. All of those images are supposed to use the same header. Okay, I'm good with that, right? Yes, we can tell that much information with this number. And that number is called the service object pair. Now, on top of that, you'll see things that are called UIDs, unique identifiers. The unique identifier is a way of identifying that file so that that file does not conflict name-wise with any other file in the world. That is to say that file has a unique identifier. It's, hi, I'm this file. I was created at this date and this time on this machine with this location code. Here's the serial number. Here's the machine's number. What is the probability of that being the same if I were to take that file and say, I don't know, transfer it to Taiwan? Could I load it into their system and it not conflict with any other file that they have? Yes. All of these file names are unique. So, transfer syntax. This is the way I'm going to send information. Notice that's not Indian, daughter feather. That is, you like that one? Was that a good joke? Okay. It is not Indian, it is Andean. Which end do I start on? Do I start on the big end of the number or the little end on the number? For example, if I say I have to send you the number, the time right now is 4:43, did I start with the hour or did I start with the minute? Do you see what I'm saying? The way I hand you the information is important all of a sudden, isn't it? That's all that means. Which way am I sending you the information? Most of you, I'm sure, assumed that was hour, then minute, tens, then minute, ones, right? So value representation and value multiplicity. Value representation is how am I going to present the data? Today is what? 11/09/2020? Not 2020, 11/09? See what I mean? How do I represent the data? What format is it in? Value multiplicity is number of times. Now that might not seem very important to you, but we do limit the number of times you can repeat a data. For example, I have a series information. That series was on this day and this day and this day. Well, wait, why would you need multiple days for a study? It's called nuke med. You inject a patient, okay, see you tomorrow, right? So you might have multiple dates for the same thing. You might have multiple names. Used to be a lot more important when we had a person by the name of Chad Ochocinco. There's also Chad Johnson, right? I have a person by the name of Sean Combs, P. Diddy, Puff Daddy. Which name are we at now? How many times are you going to send me a name for the same person? I need to know. That's all value multiplicity means. Here's what a header looks like. A header has a tag, a subject, and then a line item. The subjects are 02, 08 here. Those are the items. Notice that we've got some information here as how the study, the 02 section, how is the study sent, right? The 08 section, we've got things that are relevant to the machine and the actual study itself. That is to say, you know, its acquisition date, the study series, you know, all that other stuff. I'm not going to read what you got on the screen in front of you, but you get the point. And you've got this data that's separated into these categories. The categories are right here. And you can look them up in this web reference. The file itself, if its information is relevant to how it's transferred, is in the 02 and then something. If it's the study, it's 08 patient. They're going to tell you right now, here's a great job interview question. They'll ask you, what is a DICOM header element 1010? 0010, comma 0010, it's patient name, right? Notice that 18 has to do not just with the study, but how was it taken? What were the settings? What was the KVP? What was the MA? What was the position of the patient, right? Series information. Is this information relevant to, there again, nuke med or CT, the same patient, right? And then there's some information as to how to display. Notice something weird about all of these? They're all what? They're all even. They're all even. In order for DICOM to be accepted by the OEMs that ultimately pushed for it, the OEMs wanted their ability to transfer proprietary encrypted data. That proprietary encrypted data is called private data, and it will be listed with an odd number. So if you see a header element with an odd number, understand that that was something that was relevant to that machine, that is similar to the number that it's around, but is not something that the manufacturer is going to tell you, because it's not critical to the operation of the file. It's critical to the operation of that brand. This is where GE or Philips or Siemens will tell you, well, our images look best on our machines. Yes, you can use our images on anyone's machine, but we reserve certain processing things just for us. Well, thank you for throwing a nice little subtle, not a roadblock, but speed bump out in front of anyone else with when it comes to matters of patient health. But, you know, look, legally they gave you an image that was acceptable, it was within the resolutions that you were looking for, and you were able to display it, right? Does that mean they did their job? Legally, yes. Well, we can argue morals all we want. In fact, if you look at the right to repair people, that's exactly what they're doing, right? So let's move on. Okay, so we talked about the header information. I'm going to go ahead and I'm going to skip that file because I think I was able to explain that. Now, here's the thing about headers. Some SCUs and some SCPs require certain elements or they will not handle the image. Those are called required tags. You have to have these things or else we will not display it. I'm just going to go ahead and move on. I'm running a little short on time. Header Lab. You look for something called the DVTK, the DICOM Validation Toolkit. You will have the tools of a tax administrator. You will be able to see the header for the file. You'll be able to look at all of the elements of it. So when you've downloaded that image and you've sent it back and forth and you've got it on your workstation, you can go ahead and you can look at the file structure as to how it saved the patient's image. You can actually go into the patient's image, open that image with the DVTK toolkit and look at the header. Cool, huh? Here's the thing, because some header elements are required, in the early days of implementation, PACS admins were pulling their hair out because some machines were sending the elements and some weren't. That's a headache, isn't it? I had one CT machine that, no lie, every study had to be patched. Every single image. That meant my PACS admin in the early days had to open up every header and change them. All 150 for those images for that patient times the number of patients that day. That sucked, right? We had to get an adapter for something called the DICOM box, but you can look that up later. Okay, so moving along here, let's talk about conformance statements. When you have a conformance statement, the conformance statement is produced by the manufacturer and it tells you these things. It tells you these 7 things. These 7 things need to be right. Number 1, it tells you what the machine was intended to do. That's more important than you may believe. Trust me, we get sometimes people say, hey, I want to have this machine because it does 4D, and you buy the machine and then you find out that's an option, right? And that's poor capital management follow through. And that happens, unfortunately, right? Or you find out the hard way that the machine can do it, but doesn't know how to transfer it. Yeah, you're over there laughing because guess what? It happens. So going through the description of how the machine was intended to be used, a lot of people blow over it. They shouldn't. They should actually read this stuff because that's important. The compatible SOPs, that is to say, I am a user. Notice the SCU, SCP, and the SOPs will usually be listed together. I am intended to be used as a modality, so I am an SCU only, and I can do this. For example, I said ultrasound earlier. I said I'm ultrasound multi-frame image, which means I can send you one header and multiple JPEGs, and they all use the same header. Just go with that, right? Yes, sir.
So using the same example of ultrasound sending multiple images,
Mhm.
during the configuration of that, if by mistake it was put as a single frame.
Yes, okay. The question was, if you mess that up, would that make a difference on the operation? Absolutely. What would happen is if the machine was an SCU using the multi-frame SOP only, and your archive didn't understand what multi-frame meant, it will not receive the image. And that is where you were supposed to go through the conformance statement, and you were supposed to look these things up during the capital management acquisition part. How many times do you think people are going through conformance statements during purchasing and actually making sure that the machine will actually work on your network? You instinctively shook your head no. Exactly. You see what I'm saying? So these conformance statements become actually important. These conformance statements are listed online, by the way. It'll tell you things like the maximum number of associations. How many simultaneous communications can that do? That might not be important if you have an X-ray system. That might be really important if you have an archive and find out the hard way it was only designed to talk to 5 people at a time. Right? The endian. What formats does it want to, how does it want to have the data sent, right? What header elements are required, and what type of network it was designed to work on. Those are all very important things that you need to know about. And they're all listed in the conformance statements. The conformance statements themselves look like this. These are SOP classes. Sometimes they give you a number. Nowadays, they've been very good. They've been telling you what it will do. Notice it tells you what it can do. Notice here under study route information model move, does it work as a provider? No. Query retrieve, study route information model find. Does it work as a provider? No. That means, can I work as a client and search someone else and work as a user? Yes. So I can actually search someone else's machine. Can someone search my machine as with me working as a server? No. My machine will not allow another machine to search the things that are stored on it because it's not running an SCP software for that. However, if you look at verification, can it work as a server and send information back to somebody else? Yes. So it's not fair to say that this device is not, it's not exclusively an SCU. It's not exclusively that. It's a role that it plays. You see what I'm saying? Remember when I told you software is like a person living in an apartment. Can I have more than one person living in an apartment building? That's the purpose of them, right? So conformance statements, they help you with the best practices of things working. They can be lengthy. Folks, I've seen them over 200 pages long, describing every interaction you can possibly have with another. You're supposed to look at them when purchasing capital equipment. Do you mean to tell me that you think that that capital equipment purchases are actually going to include all biomeds and all decisions? They're going to actually tell you, hey, we want to purchase this ultrasound machine. Or are you just going to come into work one day and they're going to say, hey, we got a new ultrasound machine. Great, when's it coming? It's here now.
The loading dock.
Yeah, it's at the loading dock. Could you check it in? Did anyone even bother to see if this thing works as advertised and is compatible with our network? No. We're supposed to check that? You see what I'm saying? Maybe in your check-in procedures, you should pull the conformance statements of your archive and that machine just to make sure that the two will work together, right? That should be part of your checkout before even accepting that machine. See why I cover this? So, moving on here. Look at this before installing the device. Don't install the device, then look at the conformance statement and realize that you just wasted several times and probably bought it because you unboxed it, right? Watch out for network expansions. A lot of times people change the network. One of the worst things is they'll go to Cisco. Cisco has something called half duplex or full duplex. By default, Cisco does full duplex. If you'd like to know half duplex or simplex is what we're doing now, you talk, I talk, we take turns. Full duplex is more like children at the mall, where they're both chattering in both directions simultaneously. It's faster. What if your machine is incompatible with that? You see what I'm saying? Now all of a sudden the network sections become very important. So what do I suggest? Go home, look up conformance statements. You literally just look it up. You type, you know, Philips ultrasound, IU22 conformance statement. My archive is I don't know, impacts. I obviously don't have current information here, but you know, the truth of the matter is these things are all listed. You just go home, you look them up. You look for these conformance statements and ask yourself the question, are these things compatible? Remember, the four things that you're going to be, or not four things, the seven things that conformance statement are going to do is describe what the machine was going to do, what capabilities it has, that's the SOP, and how it was it supposed to be a user or a provider? Is it a client or a server? Or both? Can be both, right? How many people was it going to talk to at one particular time? How was it going to transfer the images? What header elements, that's really big, are required by this machine? And what type of network was it designed to work on? Very important pieces of information. Folks, I appreciate you listening to me go on and on for an hour about DICOM.